Hello, this is Dean again, just talking about PS4000 and showing you how to create a program file for a typical application using the templates. At this stage of the project, we have completed the locations tab. And we have introduced a DDC controller, and we have imported the points list, and we have the terminal view, and we've allocated the points that we need for our project. There's one point we haven't allocated, and that's just as a refresh. So I go onto the plants tab. I need to allocate the outside air sensor. I find my heating zone, and I refresh the text table on the product category where I can find my sensors, and I will find an outside air sensor. I will enable the terminal by decoupling anything that's on it, just to make sure the database is clear on that point, and then I will drag the outside air sensor onto that pin. Now you'll notice that I've previously reduced the long text names of all the other points, and to recap, all I do is double click on it and remove the text on the outside air temperature. Now all my pins are allocated, I can shut down the text table and I can progress onto the tab 4000 page. Now on the tab 4000 page, I've already completed the reduction of the names of the pins, and to do that all you do is double click on the pin header and take away the text that you're not interested in. Now all my pins are ready to be allocated onto my strategy. So I've finished now with the terminal view. You can see the terminal view is allocated. I want to go on to drawings now. Now the drawings are made available when you start to program the DDC controller. The DDC controller is made up of a folder strategy where it gives you already group 0 and plant 0. Inside plant 0 we have group 0, and inside there we have all the standard outstation configuration information, such as the CAN bus settings, backnet settings, IP addresses, lots of additional information which we've previously set up on another video. Or if you haven't watched it yet, there's one on configuring the DDC controller with default settings. That is setting up the IP address, etc. Okay, so what we need to do is we need to introduce our program. What we have here, if we look at the points list, we've got an outside air temperature, space tensor, VT flow temp, common flow, common return, HWS flow, HWS circ, pump, VT valve, VT pump flow switch, day extension timer, 2 boilers, 2 VT pumps, and a primary hot water pump. So basically what we've got is 1 VT circuit, 2 boilers, 2 VT pumps with a flow switch, we've got an extension button, and we've got a hot water tank. So the first template I'm going to introduce would be a VT heating loop. So I literally right click on the DDC 420 tab, I click on new, and I open up my template library with the 3 little dots on the button, and I can now browse my template tree and look for optimized VT heating zones, and I have here some options. I have zone 1, zone 2 and zone 3 to choose from. All of them are identical in the software. The only difference between zone 1, zone 2 and zone 3 is the labeling inside, and that is respectful of the end user once these templates have been used. If I have to program 3 zones and they are all identical, I choose the identical template from zone 1, zone 2 and zone 3, and when we've imported that for the end user, the user interface is also labelled up as zone 1, zone 2 and zone 3. If I pulled in zone 1 3 times, I would have 3 zone 1s, and that wouldn't be a little bit of extra work for you to relabel everything. So I've already done all the hard work. So what are the differences between the zone 1 schemes? Zone 1 VT valve control with template pump, and zone 1 VT valve control with integral pump. Okay, so the difference here is that the scheme number 1020 has the software hook or software connection point where you can easily attach a pump template. The 1021 has no hook for a template. The pump is already part of the software. So the differences would be, this has got a single pump, but this may have different types of pumps connected. So they might have a twin pump, might be inverter pumps, might be pumps with flow switch, pumps with fault statuses, different configurations of twin-headed pumps. So you make your choice really. So I'm going to show you how to pull in a template with twin pumps. So I'm going to select 1020, and to do that I just double click. Now this is an important step. The template hasn't already been assigned. I have to drop down the little arrow box, and you'll see that 1020 appears in the history of what I've previously used. So each time you select to load a template, if you've already used it, then you must find it in the drop down menu box list. So I now select the template. You can put your mouse on top and it will tell you the label of the template, and it's 1020, and then I double click on the plant label to load that template into my PS4000 file, and as you can see I've got zone 1 heating. To add my next template, I repeat the process. This time I'm going to add my twin VT pumps. So I select 3 little dots, go to templates, choose twin pumps, and I'm looking for zone 1 twin pumps with flow DPS. So same again, I've got pumps for zone 1, zone 2 and zone 3. These have got flow DPS, these do not have flow DPS. Okay, so they're the difference between the two VT pump sets. So I'm going to choose 0621 zone 1 twin VT pumps, weekly changeover with a flow switch for flow detection failure. Okay, I just check my list. Zone 1 twin VT pumps, weekly change with flow DPS 0621. Double click. Okay, my next template is going to be a hot water clarifier. I'll go to templates, choose HWS Temp Control, and I have a temperature sensor, I have a primary pump, and I have a circulation pump. So I will choose 0520. The difference between 0520 and 0521 is that 0521 has an anti-Legionella cycle inside, and that will require a tank sensor, which I don't have. So 0520 is the one I'm going to run with. Double click, and again, if I've previously used it, I find it in my list 0520 and say OK. My next application is for my boilers. I'm going to find a 2 boiler scheme. Select the 3 little dots, templates, boiler control, and here are my various boiler schemes dependent upon flow or return temperature sensor, depending if I've got 0 to 10 volt control. All of the schemes with 0 to 10 volt also have on-off control enable. There is some parameterization on that template we need to consider, but simple schemes for 1 or 2 boilers do have on-off only applications. So for example, what we have here, I've got flow and return sensors on my system. I'm going to choose 0822, which does also provide 0 to 10 volt demand control, and I'll show you in this video how to adjust the settings so it's more attuned to doing on-offs only, even though the 0 to 10 volt ramps will still be in the background. So 0822. 0822 is in the list, and double click. Okay, so now you can see my system's building up. I've got my VT heating loop, I've got my VT pumps, I've got my hot water service, and I've got my boilers. One little thing I haven't done is I haven't added in my primary pump. So I'm going to show you how to create space now. This would be the same order that the user would see on the interface. So groups 1, 2, 3 and 4. So I'll just minimize the hot water service again. So if I want my hot water pump, my hot water primary pump, to come underneath the hot water service tab and above the boiler tab, I can renumber the boiler tab by right clicking on it and go to the properties tab and change boilers to be group 5. This now leaves the space for group 4, and I can now right click and insert a hot water primary pump, which is a single pump. So I'll go to templates, single pumps. I've got single HWS primary pump with a built-in override feature, so just for manual override for the end user. Template number 0613. I'll double click on that. 0613 hasn't been used, so it's come straight into availability, and I just double click, and I've added in my hot water primary pump. Okay, so I've got all my main plant items. The only one outstanding now is the overrides options, where we like to have season selection, time extensions, or plant override facilities where we can just bypass and override the time schedules. So to do that, I've got some special templates. Right click on the group 0 again, select new, and this time we go into the template selection for override options. Now the override options are already pre-constructed to suit how many zones of heating you have and if you have hot water or not. So we have one zone of heating, and we have a hot water system, and we have a boiler. So the 9903 is the perfect solution for us. One zone of heating, hot water. The boiler override is the boiler service start and monitoring. So this will tell us if the boilers are actually in a service mode, and you can actually initiate the service mode. Summer and holiday, they're more building overrides, which would affect the heating and hot water, and they're software buttons as well, so you can actually use that with the user interface. So 9903 is the one I'm going to go for, and I'm going to add that in. So now all of my group items are complete. The task now is to allocate the I/O onto the associated templates and then link the templates together so the software becomes functional. Okay, so to do that, what we do is we open up the template connect pages on each of the templates. You don't have to do them all at once, but I'll do that just to show you how this concept works. Okay, so this is template connect for zone 1 heating. Okay, so we literally just put our mouse on the template connection objects, and they tell us what type of information is required for the template to function. So this is the zone 1 heating template connection, and this is the I/O connections, and pin number 1 is asking for the outside air temperature sensor. So I go down to my inputs and outputs for the controller, I take my outside air temperature sensor and I drag it onto the template connect for outside air temperature. I take the space temperature, which is the next sensor, and I take the VT flow temperature, which is the next one. If you're unsure, you can just hover your mouse over there and then reflect on which inputs have already been dragged in. Okay, so pin number 4 is the heating set point demands. This is our calculated heating set point. We're going to connect that directly into the boiler loop, and we'll do that when we connect to the boiler template connect. The next pin, number 5, is the VT valve, and I just take the VT valve 0 to 10 volt output and drop that onto pin number 5. Now we're into the overrides for the heating system. So these are the time extension buttons, and these are the nighttime overrides, holiday switches, summer switches. So for that, I go to the template connect on the overrides page. So all my connections are from template connect to template connect, and this is where I find my heating zone number 1 override connections. This is the day mode connection, and I drop that onto pin number 21. The night mode comes onto pin number 22, and then the whole building override, which will be my summer and holiday overrides, summer onto 23 and holiday onto 24. So using the user interface, when we go into overrides, the customer can put the control into a holiday mode, and that will then have the consequential software effect on the control loop and put it into frost protection. Likewise, if you press the time extension button, that will bring it into day mode, and the day mode command will turn on, and pin number 21 will turn on and have the ongoing software effect on the rest of the logic. Okay, boiler service mode is active, so if the customer uses the boiler service function in the overrides menu, we want to have the influence over the heating valves and heating pumps. So we want to trigger them to the valve to fully open, the pump to run. So we need to understand if the boilers are actually in service mode. So we go to the boiler template connect, and we look at the boiler service connection, and we look for chimney sweep is active, and we drag this connection onto pin number 26, and that will be the effect. If we have a common alarm input from the controller, so we're monitoring boiler faults, pump faults, or anything that would prevent the heating from running, we can make a connection onto pin number 28, and that will halt the optimizer from adapting. On this scheme, I do not have a common alarm or a safety circuit, so that would be where I would connect it though. Okay, the pin number 27 is pump call, and this is the template connection request which we will take to our VT pumps, and this will be the start request for the VT pumps. If I'm using a raise lower actuator, I can take my digital outputs and drop them onto this connection here. This would be the open connection, this would be the closed connection. The software is already pre-written to control either a 0 to 10 volt or a raise lower valve. There's also a heat demand output, should this literally be a zone valve, which is looking for opening a valve on an on-off basis when the system is on during the day, and it will close when it's off during the night unless it's a frost condition. This could also be used to request an external heat source, such as some kind of external request, maybe into a third-party control system, which was just an on-off request. Okay, we have one more connection to make, and this comes from the boilers, where the boilers are responsible for monitoring the return frost. We have a template connection for frost, and this is in the input and output section. And again, if the boilers detect frost, we want to have an influence over the heating circuit and bring that on and open the valves and control the heating to get the boiler return water circulating through the plant in case there's a risk of a frozen pipe. Okay, so those are the connections, and we are now literally waiting to make just the one connection now, which would then complete the integration of the heating circuit. So what I need to do next is I'm just going to work down the strategy that I've imported. I'm now going to do template connect for the VT pumps, and I'll show you how that works. Okay, so a lot simpler. This is my pump start stop, this is my flow switch, this is my pump 1 physical connection, this is my pump 2 physical connection. So my pump start stop connection comes from zone 1 heating template connect on inputs and outputs. We just discussed it. I find it in the tree on the left hand side, pin number 27, pump call. I drop that onto the heating pump request start signal. Okay, the next pin is my differential pressure switch, which is my flow detection. I now go and grab that from my inputs and outputs, VT pump flow switch. And finally, all I have to do is drop my VT pump 1 enable and VT pump 2 enable onto the connection block. So my pumps are all programmed. The software is already pre-written, and you can go and inspect that or copy it and play with it and make changes to the settings as you require. The pumps will auto rotate. They have a weekly rotation schedule. They rotate on a time schedule. You can change the time schedule here. You can specify an overrun time if you want to. The software tells you which pump is lead and which one is lag. You also have minimum. You also have a pump exercise routine built in, and you also have hours run counting. Should a pump fail, it will latch out and the standby pump will run. To reset the failed pump, what you have to do is in the user interface you can manually change the status of the pump to on or to off, and then put it back to auto, and that will reset the lead pump logic. Alternatively, at the end of each day the logic is reset, and the following day the pumps will try to reinitialize the correct lead pump. Okay, so the pumps are programmed. I'm going to close down the pump strategy by clicking on the cross at the top right. It's doing a save, never a bad thing. The software does look after you. You can see now, because of the zone 1 heating template connect, you'll see that there's actually a connection now on the pump call. As we made that connection to the pumps, the software makes that binding link to the pin for pump call. So as you create your software, you can see where you've connected and where you haven't. So it's a good check to make sure you've got all the right connections in place. Okay, so moving on. I'm just going to close some of these up to make the view a little bit easier. So I've finished with the pumps. Now a hot water service template connect, and open that software up. Again, I've got a block of information. This is a little bit different to the other template connects we have. You'll see that some of the connections we could make are not being used. They're not being taken off into other software locations. So the sensor that's being used is actually only pin number 2. So I'm going to connect pin number 2 with my hot water flow sensor. Okay, that's that done. The next connections I need to make. Current demand is the primary set point, which we'll take to our boilers shortly. On other templates, this is where I would connect a control valve. We don't have that on this application. Pin number 21 is now my override connection, where I go to my overrides page. So I find that in my overrides tree, template connect, and now I don't need the heating one, I want the hot water heating. This is where on will connect. This is the override off. Again, if you've got extension buttons for your hot water, or you've got a software time override, which the override page will give you. If I've got a high limit stat, I can connect it on pin 23. Holiday mode, which I've got from the overrides page, will come on to 24. And this is where I've got a safety circuit if I've got that as an input on the controller. Okay, heat demand, again a bit like the heating system, that would be where I could request external heat, or I could use that for like a primary valve or an on-off valve. This is the connection from my primary pump, which I will take to my primary pump template, and this is the HWS circulation pump control. So I'll go to my digital output from my HWS circ pump and drop that onto pin number 28. Okay, there's some extra software here. If you require HWS priority, you can take this T value here and take it to the timed override for the off flag in the overrides menu for the heating loops, and that will then turn the heating off for a short period, which is settable on this timer here, should there be a hot water demand after a certain period of time when there's no satisfied hot water. Okay, if you have a destratification pump, you can also connect the pump onto this pin here, and if you have a destrat fault monitoring, you can actually connect the fault message here. Okay. On our software, we do not have a destratification pump, so I can go back to the hot water menu, I can click on destratification pump, I can right click on it, and I can click on delete. Now my destratification pump is no longer required, so it's now removed. Okay, now progressing, we've got the hot water primary pump to connect, so let's double click on that, and this is where I simply bring in the request for the hot water primary pump, and that comes from template connect, inputs and outputs, primary pump call, and I just drop that onto the primary pump request, and this is where I connect my primary pump physical connection, my digital output. So find that in my inputs and outputs, and just drop that on there. So the software is very simple. These are the requests for the pump to run, and this is the physical connection for the actual output. So it's only 2 connections, and I've programmed my pump. The user interface is already preset. This is the object that gives us the ability to program the pump. It handles the hours run calculations, gives me a manual override capability. This object here allows me to program the hours run setting if I wanted to have that, which I do because it's a primary pump, and it will need to run if the boilers have just fired. Pump overrun period is default to 10 minutes. I can change that. I can put that to 15 minutes. If you're ever unsure about which templates have been used, if you look in the bottom right hand corner of the top page of inside the template, so this is page number 1, you can see that this is group number 1. In the bottom left hand corner there will always be a small timer object, and the label of the timer will be the object template number. So this is 0613, and if I look at the hot water template, this is 0520, zone 1 heating. Just as an example, this is 1020, and you can match these numbers with the documentation in the template folder to produce your O&Ms. Okay, so moving on, I've programmed my hot water, I've programmed my primary pump. Now I just have to program my boilers, and yet again I go on to template connect. Again, I just follow the list, So I have boiler flow temp, which is common flow temp. I have common return temperature. This is if I have a primary circuit, I may want to bring in a flow switch. If the flow switch is connected, then it will hold the boilers off if the flow switch is not made. When the flow switch is made, the boilers will be allowed to run. If there's no connection, it will assume that the flow switch is made. 22, there's no connection required. 23 is the boiler frost condition, which we've already taken up to our heating circuit or any other heating circuit we may have. If I've got individual boiler shunt pumps, I can connect those onto 24 or 25, and depending on how many boilers I've got, these will also become active. This is the boiler service initialization trigger. I take this from the overrides page for the boiler connection. So I go template to them in overrides, template connect, and I'm looking for the boiler service, and there's the trigger there, start boiler service, and I drop that onto the boiler service page. The only connections now to make to the boilers are to the boilers themselves, but also the set points from the heating circuits. So zone 1 heating, template connect. There is, in the input and output connections, is the current demand from the heating circuit. I drop that onto the object for the set points. I can have 7 set points coming into this object. If I needed more set points coming in, I just simply add another averaging object, which would take the highest value and bring it in on one of the pins. If I now connect to the hot water service template connect, and there's also the primary set point demand for the hot water, and drop that in. So the software is already configured to accept the highest set point from any remote zone. If there is no set point, then the boilers will stop and they'll just go into frost protection mode. So it's purely demand controlled. Here I have the connections for the boilers. So this is boiler 1 and boiler 2. Boiler 1 has a connection option for a 0 to 10 volt signal, so does boiler 2, and these are the enable signals for boiler 1 and boiler 2. So that's what I need to take. I go to my inputs and outputs, find boiler number 1 enable, and drop that onto pin number 2, and boiler number 2 to its pin number 2. Okay. Now each boiler in software will still have the opportunity to be connected to a 0 to 10 volt ramp. The standard 0 to 10 volt software is written in such a way that the boilers will be enabled and then they will follow the ramps. So the enables are clustered at an early part of the sequence. This means that we enable them, then we allow the ramps to run. So the sequence menu object here is what triggers the boilers to run over their modes. So the setting I need to change now, because I'm not going to use the 0 to 10 volt ramps, is this parameter here, which is YS1 end, and I need to set that to be 100. Okay. On the training courses we'll explore more why, or you can drop me an email and I'll explain in more detail. But that's only if you've got purely on-off boilers and you're using this template 0822, and that will be the same for any multi-stage template which has got 0 to 10 volt signals and enable signals. Okay, so the boilers are all configured now. The template will provide you with sequence rotation, you've got boiler minimum, boiler maximum, and they're all completely demand controlled. The boiler lead will rotate on a weekly basis, and they will modulate to serve the highest set point from any demand. You can also tune that set point with an offset which will appear on the customer interface. Okay. So that's the software complete. We just have one more connection to make, and that's on the boiler service template connect. Okay, because what we do in software is we provide feedback to say that the boilers are actually running in a service mode. So one condition is to request the service mode. The next condition is to say the service mode has actually occurred. So we get that feedback from the boiler service template connect, and we say chimney sweep is active, and we drop that back onto the boiler service object, which is saying that service is active, and that just makes a little indication light comes on the user interface. We've just got two more connections. I've just remembered we've got to bring in the holiday button and the time extension button. So we drop down to I'm on the overrides page template connect. If I scroll to the top, you'll see we've got whole building override, heating zone override, and on pin number 3 for heating zone override, we've got the extension timer, which is where we connect our physical extension button, which is pin number 10 on our strategy, and I drop that onto that connection. If I want to use the same timer for the hot water menu also has an extension button connection. This could be unique to the hot water, or we can share it as a common time extension feature. If I scroll down a little bit further, this is where I connect some physical summer winter holiday switches. I've got a summer switch connection and a holiday switch connection. We don't have either, so we're just going to rely on the customer using the software connections, which are in the overrides menu. Okay, so the whole program is complete, and I'm sure you can appreciate without all the narrative we could have done that quite a lot faster. But now we've just programmed a bespoke heating system with 2 VT pumps, hot water tank temperature control, primary pump control, 2 boilers with auto rotation, and we've got a full suite of overrides and interlocks to complement that. At this stage, what I can do is I can right click on zone 1 heating and choose properties, and I can say what that zone actually is. So let's say this is the school heating, maybe, or junior school. Let's say infants. You have the option to do this, you don't have to. This would make this the infants pumps. Just doing a save. Properties, and that will become the infants VT pumps, and you can continue making label changes like that as you need. Now what we have to do is we need to compile the software. So to do that, we right click on the DDC420 and select project planning file, and we say create DDC without security. We give this a file name. I'll call this version 1, and we say save. Now all of our software is being created, and once this is compiled, we'll be in a position to download this into the controller, and that'll be the purpose of the next video. Thank you very much.